So welcome to another TouchDesigner Meetup. So this one's gonna be about shaders. My name is Bileam. I'm gonna be your host, and we have technically we have three presenters. One hasn't showed up yet, so we're here with two lovely presenters, Tommy, also known as Tekt, and Joseph. And they're both gonna share their amazing projects created in TouchDesigner with shaders, and they're both very elaborate, very complex projects, I would say, long-term things. So I'm really excited about this. Also, like along with pops, it just seems like there's a lot happening in the 3D world now with TouchDesigner. So I'm very curious to see what you came up with. And we're gonna start with Tommy, Tekt. So yeah, and by the way, this is gonna be recorded, and yeah, usually as usual, we're gonna have a kind of a discussion in the meetup room afterwards. So if you have any questions, just note them down. We're gonna do that afterwards in the other room. So for now, just enjoy the presentations.
Cool. Can you hear me? Awesome. Okay. Let me pull this up. All right. So what we're going to be talking about today is Ray2K. You may or may not be familiar with that, but it's a project that I've been working on for a few years now. So before we get too much further into that, um, just a little bit about who I am. So my name's Tommy Etkin. I go by the name Tekt. I am an artist and a programmer. I'm based in Los Angeles in California, and I've been using TouchDesigner since about 2012, and doing a lot of like projection mapping and video processing and different kinds of rendering. And shaders were kind of more of a. It took me a number of years before I like started actually delving into shaders because they were kind of intimidating. But so I'm also co-founder of Immerse Studio, which is a collection of a couple of artists and that we work on kind of commercial projects around like video, projection mapping or kind of like brand activation, interactive pieces, that sort of thing. Because I eventually realized that it's a whole lot easier to get things done if you have a team than if you're just trying to do everything yourself. All right, so now getting to good part. So Ray2K. So in a way, like Ray2K is kind of about not having to write shaders, or I guess in the sense that I write the shaders that you don't have to, unless you want to. Uh, the idea is that it's kind of a distinct family of operators, like kind of like chops or dats or zops or whatever. Uh, and so you use a bunch of those to define a scene, and then there's a renderer that uses the operators that you've connected into it to build a shader in the background and run it to produce different kinds of images. And then there's also a set of tools for working with those, like a palette for creating new operators. I'm not sure if that, oh yeah, that does go through. Okay. Um, and uh, yeah, just different kind of like workflow tools to make it easier to build out content with these operators. Uh, so why did I do this? Sort of two reasons. Like one is rate marching is amazing. I for years had been seeing stuff on Shader Toy, a lot of work of Inigo Puez, like this example here. This is a shader with no geometry in it. There's no model, there's no textures, there's nothing aside from code. Um, and the yeah, so that was kind of like uh I don't know. I couldn't quite figure out like how that could be possible. I sit there and look through the code, and there is a lot of code. Um, and couldn't quite figure out like how that resulted in a scene that looks anything like that. Um, so I found that to be kind of intimidating, um, and avoided it for many years. But then, like right at the beginning of 2020, I decided that it was worth kind of trying to get over that and like see if I can make it work. And I found some tutorials and pieced together a few little bits that kind of worked. Um, and then let's see if this comes up. Okay. And then I encountered Patrick Lechner's TD Raymarch toolkit. So this is kind of a precursor to RayTK. I think it was created sort of for for educational purposes, but I may be wrong about that. But a lot of the kind of core elements of RayTK are there in that you're kind of wiring up a network of operators to add bits of code to create a shader and run it. There were some kind of key differences. He put a lot of effort into making it feel like regular TouchDesigner operators, where every different operator has its own little viewer in it, um, which was a really nice feature in terms of making it feel just like regular operators, but it had a really huge performance cost because it had to run a whole separate render pipeline for every operator. So I started working with that and trying to use it. And then as I was using it, I found various things that I would have done that a little bit differently, or like different, features that I wanted to add. So I started kind of modifying it. And then closer to the end of 2020, I decided that it was time to kind of rebuild the thing from the ground up, um, specifically with the purpose of making it something that I could share with the community, that other people could use, that would be intuitive to use, and would be designed to be, you know, used to create content that would continue to work, um, and not like be dependent on changes in a library. Because one of the challenges that I had with that first year of working with it was that I was simultaneously like building the tool and using the tool. So as I was creating content and making changes to the library, I went back to my older content and none of it worked because I had changed everything. So I decided that it was time to do a full rebuild of the whole thing. So this is just one of the elements of like how an individual um, how a renderer like builds the shader and stuff. So lots of stuff like that. But the idea was that it's going to be built for the purpose of being like portable, reusable, and intuitive. So what does it do? So the main thing that it does is called ray marching, which is a technique of rendering where you are kind of simulating like a ray going out from a camera position through a scene. And so if you have like a little screen there, so each pixel on there gets a ray that starts at the camera and then goes out into the scene. And then as it's going, it's checking the contents of the scene to see if it's hit anything yet. And when it does hit something, then it uses the properties of that surface and the lighting, whatever, to pick a color. So what that looks like in practice is it's something like either of these. And there are, and the kind of nice thing about it is that there are things that are easy to do in ray marching that are really hard to do with a traditional render pipeline. Conversely, there are also some things that are really easy to do in a traditional render pipeline that are really hard to do in ray marching. One of those being applying textures to surfaces. But uh, it gives you kind of a different set of capabilities and um, different ways of working with space and geometry. And so that's kind of been, and so I've spent a few years now, like kind of exploring that, like figuring out new ways to expand the capabilities of the library. and um, all kind of building on that original vision of like not have making helping people avoid having to write shaders to do this stuff while still making it like accessible. Uh, so that was kind of the original purpose of the library, and so it also does other stuff now. So one of the one of the things that I added during that like rebuild process was the idea of like ray marching is one of the different kinds of rendering that it can do, but there are others too. So I built in a whole two-dimensional system, which there are different operators that generate patterns and transforms and stuff that work in 3 dimensions, often also work in 2 dimensions. And so these operators can be used um, for things like patterns on 3 dimensional surfaces, but I also just made a little renderer that is just a 2D, basically like pattern generator, and it can also take texture input, so you can use it basically to like make your own tops in a sense. And let's see, it takes a second for things to load. The other big area is volumetric LEDs. And this was kind of a coincidence that right around the time that I was working on this, I was uh, given a commercial project at the Oklahoma City Convention Center where there were, a big 3 dimensional grid of LEDs hanging from the ceiling. Um, and they wanted to have patterns moving through it, and so the studio that I was working with, their traditional workflow is like they have this like amazingly skilled cinema 4D artist who makes these like beautiful pixel perfect animations, and then there's play on like really high resolution screens, but there is no screen here. So that workflow doesn't work. So we had to come up with something else. And it turns out that the math that's involved in figuring out if a ray has hit a surface is really applicable to figuring out what color an LED should be, figuring out if, given that position in space, if it's inside the shape or outside the shape, and then picking a color off of that. So right around then, I met some people from LED Pulse, um, which uh, they make a product that they call the Dragon, which is this like volume of really densely packed LEDs. The first install that I did was like they were very far apart, but like you're viewing them from really far distance away, so it's less about detail and more about like big motion. But LED pulse volumes are much higher density, and so I started experimenting with those. So this is just like one of the um, experiments that I've been doing somewhat recently. We also tried a few little things with like shooting lasers through it, which was kind of neat. But this is another area that like it wasn't really the purpose of the library, but it became a good tool for working with that kind of content. So what is next for ATK? So the big one right now, I think, is volumetric rendering, and this is kind of where Josef's T3D library comes in, because I would really love to be more integrated with that because there's a lot of really amazing potential there, which I guess we're going to be hearing about in a little bit. Um, but I think these are two libraries that are both dealing with defining shapes and space and volumes within 3 dimensional space. So I think there's a lot of room for those to integrate. So this example here is just like there's kind of my first attempt at doing like volumetric rendering, which is sort of for like gases and clouds and like sort of transparent things that are more like um, not glass or liquid, but like gases, clouds. But that's it was kind of like my first very like naive attempt at getting that to work. And there is way more, um, way more that can be done with that. So I think that's going to be a big area of focus. Another one is refraction. So this image here is from Tim Gerritsen's refractive ray marching course. Um, Important part here is the water and the way that light passes through it, but it gets distorted. So that's kind of been in development for a while, because I think that opens up a whole new area of content if you can have, glass and prisms and that kind of like bending of light. There's also some stuff that will be coming out pretty soon that hasn't been announced yet, but you'll be hearing more about that soon. And lastly, if you want to learn more about this, um, I have a Patreon where I put out tutorials um, and example files and scenes that you can experiment with. There is also YouTube where a lot of the like public tutorials live, and I'm also available on social media, Instagram, whatever. If you want to message me, if you have questions, or if there's stuff that you want to find out about, please let me know. And that's about it.
Thank you. Can you hear me? Yeah. Amazing. It's lovely to see an overview of that because I've only kind of heard about it and seen some examples, and it's really nice to have an actual overview and to see the capabilities. Yeah, I've definitely noted some questions. I'm gonna come back to that later on. I'm just gonna have a quick look if Jason is here. I don't think so, right? Doesn't look like it. No, so I guess we're just gonna continue right away with you, Joseph, and then afterwards we can have a bit of a discussion.
Okay, sure. Thanks a lot for the amazing presentation. I don't really have a presentation like this prepared here, so I will be a little bit more spontaneous here. But it's super nice to see your overview on RayTK again, because funnily enough, I feel like we've worked on very similar project from a slightly different angle. But yeah, what I will talk about today is T3D, and that's also a kind of operator family I created. So just like RayTK offers you a whole like universe of operators and things you can do, I also worked on a new operator family, which basically extends the idea of tops to a third dimension. So yeah, I think we're all quite familiar with tops, and some of you might have used the Texture 3D top before, which is the built-in. I will animate something here. The one built-in operator into TouchDesigner that takes a two-dimensional texture and creates a three-dimensional texture from it. And this three-dimensional texture is really just an abstraction of the idea of having information. So the way I think about a two-dimensional texture is basically I have a two-dimensional object like this rectangle, and I can sample information at any position within this two-dimensional texture. So I can ask, okay, in the middle of the texture, what color is there, or more generally, what values do I have there? And with three-dimensional textures, they are mainly represented this way. You can ask for information in a three-dimensional space, which is not like super obvious why you would want to do that in the first place. But I think like for texture 3D, for example, the third dimension is supposed to be understood like where the texture 3D top is supposed to be understood as time here, because it's also like collecting information about over time. But like if I would put this into an ad because I want to add two 2D 3D operators, I get an error because it's not supposed to, like, it's not working with 3D textures. And that I found annoying for a long while because I do quite a lot of stuff with 3D textures. And I can only do that by using GLSL nodes and outputting as 3D textures. So GLSL nodes do work with 3D textures. And over the last couple of years, I worked quite a lot with 3D textures and built my own operators. And I finally thought it's time to kind of package this into something that is usable for everyone. So I created this T3D Tox, which you can really just drag and drop into your project, and it creates a new operator family in your op-create dialog. So I spend quite a lot of time. So if you go to the uppermost level in your project and expose all, you will find that like what I'm doing behind the scenes is I create this T3D operator up here, and there's some stuff that's, yeah, like everything needs to be done in order to have this working is defined in here. And also here, all the operators that that you are then able to use. And yeah, in order to have this operator family added to your upgrade dialog and like being able to click on it, using it as it's supposed to be used, I kind of go into UI dialogs, and there's a thing that's called menu op, which is basically like taking care of this upgrade dialog and the logic behind it. And you can see that if I toggle off and on T3D, for instance, in this area, you see that I automatically create some code and change some stuff in here in order to make this happen. But yeah, let's see how this works. So the idea is really that you can work with them just as you would work with 2D textures. And I also designed them to be very close to what you know from 2D. So there would be an add, a blur, a constant, across, a displace. So all these have like direct corresponding in tops. Yeah, so I think one of the like a lot of projects you might want to start maybe with a T3D shape. Currently, there are only 3 options here that I will extend on, and it generates like a torus, a sphere, or box. And there's also like no meaningful preview of what this looks like. You just see 3D slices. But I also created a surface T3D, which takes as an input a 3D texture and renders it as a surface. And interestingly enough, this is also ray marching, just as Tommy is doing in RayTK. But I'm not ray marching a signed distance field as he is, but I'm ray marching this 3D texture, which works differently but similarly. There's a preview built in here, but it's actually a geometry. If you look at this, and you can like do all the geometry stuff you would do. But if I drop down a camera and maybe my own light, that's like the proper way to customize it, and also a render node. So I should change the material here to PBR, and probably increase the rendering resolution, and I'll reduce the roughness of it, set the background to black. Yeah, so you see now this is a more reasonable representation of this T3D shape. In this case, it's a torus. I can like change the parameters of it as expected. It could be a sphere, could be whatever. We've created spheres in SOPs for a long while, and also tori and stuff. So why is this any useful? Well, we can do stuff with textures that we cannot do with geometry that is defined by triangles. For example, we could use a displace. This works just as the 2-dimensional displace. And I could put in a noise here, which is also now 3-dimensional. I will make it non-monochrome, set the offset to 0, and maybe I should increase the resolution to something, also set a pixel format. By the way, I should also crank up the resolution of this shape. And now I can kind of really displace you see here, I displace the pixel values or the voxel or texel values of the 3D texture, and this results in a very like fluid change of the surface here. You can of course like change all the parameters, and most of them are really like as close as possible to the 2-dimensional correspondence. Yeah, and we could like, especially we can like do all this in feedback loops as we would do in 2D. And yeah, we're all very familiar with this and love it, I guess. So I could just put that in a feedback loop, and now it like morphs over time. And yeah, there's a lot of things that you can do with this. I'm already very happy to see how people use it, and yeah, what they create with it. I think, yeah, I've just loaded 2 videos to explain a little bit about how it can be used and what you can do with it. I will like publish more tutorials on this and more examples. I'm already also still like extending the palette of what is possible here. For example, just yesterday I added a top to T3D basically, which can take in any top, for example, a text. And I can put this in here, and it can either work just as the texture 3D top would do. So basically like iterates over time, with a small difference that the most recent frame is always in front. So I kind of have a more reasonable, like, yeah, it's not going through the 3 dimensions all the time, but the newest frames always in the very front. But I could also set this to not time-based, but just a plane, and then I can basically position this 2-dimensional texture with a given thickness somewhere in space, and I could already also rotate it around, scale it, whatever. This is not really interesting right now. I could have done this differently, but again, from here I can now treat it as a texture and do all kind of things. So I just blurred it a little bit to have it more smooth. I might also want this to have a pixel format with more information stored in it. And then I could, you know, maybe transform this based on noise. Bileam, by the way, let me know if I'm running out of time here. I don't really have that in mind. So I could, take a noise, maybe increase the resolution, the period, and put that in the translation here. So it's now moving through space, maybe decrease this a little bit. So it's now moving through space, but what I can do, what I wouldn't be able to do with geometry is, again, I can use a feedback and maybe a cross. So this is also a T3D operator that works exactly like the 2-dimensional correspondence. Put that in a feedback loop. And then make it such that the geometry basically like creates a trail behind itself. So I think, yeah, well, these are really like quick sketches, quick examples, but I hope you can see where this can take you. I could also, I think it's interesting to also rotate it. So I will do that. Yeah, and it also makes just like, yeah, just as you would expect with any geometry, I can mix it with any other geometry in TouchDesigner, and they blend in a reasonable way. So I can move that around, and it really like, yeah, they would like cast shadows onto each other and stuff. So yeah, I've worked on that for a while now, and I'm super happy to have released this. You can find it on my Patreon and find some examples on YouTube of how to use it. And yeah, I was very happy to hear Tommy's talk about Ray2K, because I think they are very similar problems that we solved here, and the two kits are different, but also have a lot in common. And I think they will be super powerful when they kind of work together. So I would really much be interested in. I think we should definitely build a bridge, because it should be fairly easy to translate a Ray2K operator into a 3D texture. Correct me if I'm wrong, but we can talk about that in a minute. So I think together these sets of operators will be amazingly powerful. So I'm looking forward to seeing that happening. And yeah, I think that's about it for now. I'm looking forward to like answering all your questions. This is just a quick introduction. Maybe one more thing. Yeah, I mentioned you will have this little button up here that calls itself T3D, and if I click on it, it will basically deactivate the T3D family if you ever want to get rid of it. And you can just click on it again and it will reappear here. And if you right click on that, you will get a little dialog where you see the current version you're working with, which I have not updated, I just realized. So this is actually version 1.2. It still says 1.1. Yeah, I'm still beginning with tool building, so I should work on that. You can also completely remove T3D from a TouchDesigner file. I won't do that right now, but it like will delete everything that. So it will keep your operators that you've used so far, but it will really like uninstall this thing if you ever want to do that. And you can also actually set like at what index in your upgrade dialog you want T3D to appear. Maybe you want to have it next to the tops, and you can also set the color if you want to have, I don't know, pink T3D operators. Yeah, so that's I think everything from my side when it comes to an introduction. And yeah, so yeah, maybe because we are talking about shaders here, behind everything you see here, there's a shader I've written for you. So as Tommy said, I wrote the shader so you don't have to. A lot of them are actually kind of simple, especially if you're used to doing compute shaders. Like even the blur thing it's kind of, you see, it's just a couple of lines. They are all compute shader based because compute shaders are more efficient when it comes to 3D textures. But yeah, they are also all open. So if you're wondering about how I'm rendering this, you can have a look at the shaders for rendering stuff. Yeah, I would say thank you so far, and I'm looking forward to hearing your questions and open the discussion. Thanks a lot.
Amazing, thank you. That's very, very impressive work, and it just seems that as you kind of try to create it, it seems very close to what you're already familiar with in Touch and with Tops. So I think that you did a really good job with that. So you made that. So you actually went into like the back end of TouchDesigner and changed the whole menu.
Yeah, like back and front end a little bit. Like I didn't change all too much. I just built in conditions for if someone tries to create a 3D like T3D operator, it should kind of not do the other stuff, but only that. Yeah, I mean the code is there. I mean, we can totally talk about it, but it's also funny that you can look into how I did it and maybe recreate it. And I also thought about like maybe building this into that itself into like toolkit where you basically can collect any like operator set you like and use the toolkit to make that into an operator family. I'm interested to hear, I don't know what Derivative thinks about this, because it also feels a little bit wrong to kind of go so deep into the UI. But
yeah, I mean, yeah, I really admire the way that you integrated it there. Like I ended up just making a separate thing, but it definitely makes it feel so much more natural, like just a built-in part of TouchDesigner. But yeah, I mean, the upgrade dialogue has been kind of like it's kind of archaic and needs to be replaced. But um, I think it's still built with a lot of T-script. So
But there's also a way
yeah,
to
I had
do
to learn
like
some C-script for that.
there's also a way to do custom ops, right? There's the custom tabs. Why didn't you want to use that?
Because for that, I would have to. I think you only can create the custom stuff with C++
Right.
based things, which I probably also could have done, but also that's a big barrier for me. Like I've written some C++ and CUDA stuff before, but I honestly don't know if I could write compute shaders in there or only CUDA. I'm honestly not sure. I probably could, but yeah, it felt too unfamiliar for me. It was quite easy to do it this way, and then would have been more difficult otherwise.
Seems to work perfectly. So cool, amazing. Thank you. So let's move over to the meetup room.
I think, sorry, before we move over, I think I see Jason in the chat.
So oh yeah,
he is here. You could ask him on stage.
Oh yeah, he is. Nice. Oh, that's beautiful.
Yay. I can see that.
We got you.
Thank you, everybody.
I know, or Mac for that matter. Thanks all for your help there. Thanks for your patience. So yeah, let me know if you can see this now. This is just kind of a highlight of different ways I've used particles. I do a daily sketch every day as a practice of learning new techniques, exploring different visuals. Yeah, so these are, I don't know, kind of very inspired by light and kind of forces in nature, a lot of like kind of gravitation and yeah, different forces that are natural but kind of unnatural too. So I kind of like to explore that fine line between like what we might see and then what might we not see. So these are just a set of visuals that I've created, and yeah, and the kind of brief time we might have is yeah, kind of show different examples and how I kind of thought through it and created them. So the first example I want to show is this this Lorentz attractor. It's a strange attractor. It's maybe you've seen different representations of this. Some I've seen are more sculptural, some are more like kind of wire-like. But it's basically based on a set of differential equations where the inputs are very sensitive, but then kind of converge into this form. And so what I've done here is use shaders to have a lot of particles at once and kind of noticing the aesthetic that emerges when you use a lot of particles versus just a few kind of makes it more of a kind of a ghostly form, kind of more ethereal, and I can open up the project and kind of show where the techniques I've used there. So yeah, so I think what clicked for me was like learning about how a texture, so that's a pixel shader, can be used to store different data. So like position or velocity data, color data, and really handle it all in real time in a performant manner. So my frame rate is not really high right now because streaming and the texture is pretty big. But you can kind of maybe see the texture going on right here as raw particles. But yeah, the basic kind of formula in the shader is very, very simple. Like there's like kind of three basic parameters, and then based on that, kind of feeding back on them over time creates this really interesting composition. Yeah, so I thought this might be a really good first example of how yeah, really simple kind of mathematical equations can yield really interesting results. And I'll go through kind of the different parts. Let's see. This one component is kind of like a time-based blur, which kind of takes the discrete particles and really smooths them out. So it's kind of averaging the texture over time. So I use this in a lot of my work to make it feel a little bit more smooth and yeah, kind of calming and slowing. Yeah, so that's the first one. Mac demonstration, that's bold, yes. Yeah, the second example is I got a commission just from someone on Instagram about he was a type designer and wanted to kind of promote his new typeface. So kind of taking the edges of the glyphs, I used particles to kind of create this otherworldly representation of kind of these abstract parts of the type. And so using a similar kind of setup as before, taking the particles and then affecting them at a big scale. I think one interesting thing maybe I can show here is I've basically taken like a text top and traced it, kind of converted it into a texture, basically is what I wanted to get it into, so I can manipulate it using shaders. And then from here, yeah, using just simple curl noise. If you're not familiar with curl noise, Bruno and Breezy has a good tutorial about that. Yeah, creates these really interesting swirling and kind of curvy movements. Yeah, so it's really interesting to work with kind of a new kind of base artifact and kind of taking my own spin on it. Yeah, the next one is kind of similar, but a little different. This was the first time I had done something like this. Basically, someone reached out to me about kind of visualizing scientific data. So this is an image of the Antarctic ice streams. So they're kind of trying to visualize ice melt. And so the colors kind of represent the velocity of where the ice is melting over time. So I hadn't really worked with data. As like I can just do my own style on it, and kind of similar to what I had done before, just trying to animate the particles with curl noise, but it kind of had this weird effect of like an abyss, like particles falling down into, the ether. They didn't really feel like that was realistic or helpful. Then after talking to the scientist, it turns out they had a spreadsheet of all the velocity data, and this is just a snippet of it. That like a 2000 by 1000, Excel sheet of all the velocity data, just really like 100+ megabyte file. I ended up converting it to a texture format that I could work in. EXR is nice in that it can store floats, so it could store like positive, negative numbers. And yeah, with that, I was able to use that to actually visualize the flow of the particles using the data, which is really amazing to see when I was able to get it to work. I feel like this, yeah, really kind of heightens the static image, and it's not just purely aesthetic. There is like the scientific component behind it. So that I thought that was a cool example of kind of data visualization in a new way that I hadn't experienced before. Let's see. This fourth example is wanted to share a technique that I learned from XDOS. It's basically using an SDF and calculating like its normals to affect forces of particles. So what we have here is kind of a volume sphere full of particles, and it's kind of being affected by the SDF to be constrained into that SDF. And they're also kind of the bright moments are kind of gravitational cores that are pulling the particles and kind of creating this like kind of atomic, I don't know, otherworldly space-like creature sort of thing. And it's just kind of another example of how many particles can create, yeah, when they're all kind of translucent, overlapping, can create this new kind of form that you might not see with just, say, a few large particles. With that project, I eventually kind of made it more generative, added different colors, different forces. So this is a 5x5 grid of that. I'm not sure if you can see this well, but just to demonstrate the different variations in scale of like what a simple system can be, and the different variations that can create interesting outputs. Yeah, so with this project, I actually converted this to web and released it as a generative art project. Working with shaders was really nice because I could kind of convert every GLSL top to like a render pass in iWeb kind of toolkit and translate it pretty well. The last I'll show is kind of different. Maybe you've seen LED pulses volumetric array. Just kind of wanted to share a little bit how I went about creating content for this. I know, with T3D and RayTK provide really great tools for working with this. At this point, I hadn't had used those, so I had to be a little creative. But maybe this one I can show a little bit about how I went about doing that. So yeah, basically I have some points of noise that are moving around and are with remarching, creating this like metaball shape that is you may have seen before. What's interesting about the volumetric array is that there's color inside, it's not just on the surface. So to think about that, what I did was use the SDF as the base, and then for the kind of point that you insert into the SDF, I have kind of the volumetric array kind of converted to softs, converted to a top, and I'm feeding those into the SDF. And so for every point in those, let's see, I am seeing if it's within the SDF or out. And then if it's in, I'm doing some coloring on it based on this procedural coloring where it uses just cosine formulas to create this full spectrum palette. So you can see from different angles that like inside the volume it's has its core color, and then it changes when you get outside the volume. I think RayTK has like a way to do this pretty easily, and maybe maybe T3D will as well. Those are just some examples of how I've used shaders in my work. If there are any questions, I can go.
All right, thank you. It's lovely to see a bit behind your work, because I've been following your work for, oh, he's gone. No, he's still there, okay. I've been following you for a while, and it's really nice. And I'd actually like to, if you want to share that, hear a bit more about your background. Kind of, is TouchDesigner your main job, or is it just kind of a hobby that you do?
So I was like a software engineer for some time, and then around pandemic times, 2020, it was time to do something else. I feel like a lot of people during that time pivoted in different ways. So I really wanted to do something creative again. I found creative coding and learned a lot of things from books, online resources, YouTube videos. Came across TouchDesigner in March of that year, and listened to your tutorials, Bileam, and a lot of other folks that have given to the community quite freely and openly. So very thankful for that. And then since then have created a new thing every day and posted to Instagram as a way of just like practicing, but also sharing. I treat it as a sketchbook that is kind of like anyone can look at it and see what I'm thinking about. And it's been a good way to gather a portfolio to like kind of share with others what I'm doing. And sometimes people contact me for licensing and commissions, installations, things like that.
It's always very impressive to see people actually doing daily work. Never able to actually be consistent with that, and even just seeing like the way you present like one artwork in a grid is always so cool. I think it's really one of the powers of generative art, that you can really nicely just work on one artwork and then show a lot of different versions of the same thing, different ways.
think another thing I wanted to share is about the dailies. Like, it's not always like create something new from scratch. It's yeah, it's definitely an iteration exploration process. So
Right.
oftentimes I'll open up yesterday's file, and see like where can I take this today.
Mm-hmm.
And sometimes it's like find new things. Sometimes it's a dead end. I'm like, okay, need to switch to something else.
Right.
Yeah.
Cool. I think now I'm gonna stop the recording.